Hello students, welcome back to my channel. Today I am going to discuss about the screw gauge. In my previous video I have already discussed about the vernier caliper, and today I am going to discuss about the screw gauge. I am following class 9 concise physics book for the class. Okay, now first time let's see what is a screw gauge and why it is used for. We all know that the screw gauge is used mainly to take the observation, or it is used to measure very small length or thickness like the diameter of a wire or the thickness of a paper to take a high accuracy. But to find out the observation of the screw gauge, first thing that we have to see is how to take out the pitch. The pitch. What is the pitch? Pitch is the distance, the linear distance which the screw moves in one complete round of its head is equal to the distance between the two consecutive head threads on it. This is called pitch. To find out the pitch, let me first tell you about the different parts of a screw gauge. So this is how the screw gauge looks like, and this is known as a spindle, and this spindle is a movable part. You can place an object over here. This spindle is a movable end that moves towards the start to hold the object. There is a ratchet, you can see over here, ratchet. This ratchet ensures uniform pressure during the measurement. Okay, and over here this is the start, the fixed end. This start is the fixed end. This start is the fixed end. In some book you can also find out it is written as anvil. So the fixed end where the object to be measured is placed over here. Okay, and another thing is there is a main scale and there is a circular scale. Let me show another picture. This is the main scale, this is the main scale, this is the main scale, and there is a circular scale. This is a circular scale division, and this circular scale we can rotate it. This circular scale is a rotating one. Okay, and there are, in general, there are total 100 divisions in the circular scale. There are total 100 divisions. You can see over here it is written 30, then 40. In this way there are total 100 divisions. Okay, in some cases there are also 50 divisions that vary, but in general there are 100 divisions. Now let's find out what is pitch, how to find out the pitch. Okay, so the pitch of a screw is the distance moved along its axis by the screw in one complete rotation. So in simple word, pitch is how much distance the screw moved inward or outward, how much distance the screw it moves inward or outward in one complete rotation. That is known as the pitch. How to find out the pitch? Say suppose I am taking an example like for example, a screw has rotated 1 millimeter in one rotation. So what will be the pitch? The pitch will be 1 millimeter only, because according to the formula I have told that the inward and the outward, the distance that screw is covering in one rotation, either it is moving inward or it is coming outward, I mean backward, that is known as pitch. Say for example, if a body moves, if a body or if a screw it moves 1 millimeter in two rotation, then what will be the pitch? I have to find out how much distance it covered in one rotation. Thereby in one rotation it will cover 1 by 2 millimeter. It will cover 1 by 2 millimeter, which comes out to be 0.5 mm. So that this will be the pitch. So the pitch may vary from instrument to instrument. You have to know how to find out the pitch. If it is said that a screw it moves 2 millimeter in two rotation, so 1 millimeter in one rotation, then the pitch will be 1 millimeter. The pitch it will be 1 millimeter. So in this way you should know how to find out the pitch. Okay, So first thing I have already told how to find out the pitch. Now let's find out the least count. The least count of a screw gauge. What will be the least count here? Okay, the least count of a screw is the distance moved. The distance moved along the axis by it in rotating the circular scale by one division. Okay, so the least count is you have to find out the pitch of the screw and the total number of division in the circular scale. Let's take an example. Say it is said if a screw moves 1 millimeter in one rotation, 1 millimeter in one rotation, that means pitch is equal to 1 millimeter, and it has 100 division on a circular scale. So how to find the least count? Least count is the pitch divided by number of circular scale division. So the pitch was 1 millimeter divided by there is 100 division in the circular scale, so divided by 100, so 0.01 millimeter, or in centimeter you can write 0.001 centimeter. In this way I can find out the least count. Now let's look out how to find the observation, how to find different observation. Let me find out that. There is another example. It is written, if a screw moves 1 millimeter in two rotation, 1 millimeter distance is covered in two rotation. Then in one rotation it is covering 1 by 2 millimeter, that is 0.5 millimeter. So how to find the least count? Least count is the pitch, that is I have already taken out 0.5, and total number of division in the circular scale. Let's take it as it is said over here. Its circular scale has 50 divisions, so divided by 50. 0.01 millimeter. It is 0.01 millimeter. So now you will know very well how to find out the pitch, how to find out the least count. Let's take another example. Okay, over here it is said if a screw moves 1 millimeter into rotation, 1 millimeter into rotation, 1 millimeter into rotation, that means in one rotation it will move 1 by 2 millimeter, that comes out to be 0.5 millimeter, and its circular scale has 500 division. Then what will be the least count? Least count is equal to number of the pitch rotation, number of the distance it covered in one rotation, that is 0.5, divided by there are 500 divisions, so divided by 500. Okay, so this comes out to be 0.001 millimeter. I hope there is no problem in finding out the pitch or the least count of a screw gauge. Now take a look how to find out the observe file, how to find the observation, how to take the observation. Okay, there are written about the different parts. You can go through it. The parts and their function is written over here. I'll straight go how to find out the observation. Okay, so there's a pitch. Now let's take the example of this one. Suppose this is my circular scale, and this is my circular scale. This is my circular scale, and this is my main scale. How to find out the distance? How to find out the observation? Okay. Okay, so how to find out the observation? We know that the observation, if there is no zero error, then we can find the observation, we can take the observation in this manner. If there is no zero error, what do you mean by if there is no zero error? It means that the baseline of the main scale, this is a baseline, this is a baseline, this is a baseline, and this is a circular scale division. Okay, so the case in which the baseline it is Okay, how to find out that there is no zero error? How will you find out that there is no zero error? If the baseline of the main scale is coinciding with the circular scale 0, then it is a non-zero error. Then to find out the observation, how to take the observation, we will see that if there is a non-zero error. Okay, so what is the formula? That is the main scale reading plus least count into the pth division of the circular scale which coincide with the baseline. The main scale reading plus the least count we have already found out in different portions. The into the pth division of the circular scale, that is the baseline which is coinciding with the circular scale. Let's take the example. In this case, the main scale reading is, this one is 5, 5.1, 5.2, 5.3, 5.4, 5.5. So the main scale reading is 5.5. The main scale reading is 5.5. Okay, 5.5 plus the least count. Let's take the least count as 0.01 millimeter. I am taking the least count. Least count is 0.01. So into 0.01, that is the least count, into the the division, the pth division of the circular scale that coincide with the baseline. Which one is coinciding with the baseline? This is 35, 36, 37, 38. So 38 is the one that is coinciding with the baseline. So into 38, it comes out to be 5.5 plus 0.38, which is equal to 5.58 millimeter. In this way you can take the observation if there is no zero error. What do you mean by no zero error? When the zero of the baseline, main scale reading baseline 0 is it coincide with the circular scale 0, that time there is no zero error. So the observation comes out to be 5.58. Now let's take an example of a case where there is a zero error, a positive zero error and a negative zero error. Okay, so here is a positive zero error. You can see over here that the baseline in the main scale, it is ahead of the zero of the screw gauge. So how to eliminate this one? To eliminate this one, we will take plus for the positive sign, that is a positive zero error, into the least count that I've already taken, into the baseline which is coinciding with the circular scale, the baseline which is coinciding with the pth division of the circular scale which coincide with the baseline, okay. So over here we have taken least count as taken as 0.01 millimeter. So positive 0.01 into the pth division which is coinciding with the baseline. Which one is coinciding? This is 0, this is 1, this is 2. So 2 is coinciding. So the answer 0.02 millimeter. This is a positive zero error. Now how to get the true value? What is the true value? The true value is the observed value that we have already taken. Observed value minus the error, positive zero error or negative zero error, whatever will be there, with the sign, the error with sign. In this case it is a positive zero error. Already the observed value was 5.58. If there was a positive zero error, then we have to subtract this error, minus 0.02. So it comes out to be 5.56 millimeter. This is the how to eliminate the positive zero error and to get the true value in this way. Now let's look out how to take the observation of a negative zero error. What is a negative zero error? This is a negative zero error where the circular scale 0, it is ahead of the main scale baseline 0. In this case this is negative zero error. So how to eliminate this? the negative sign, there are 100 circular, the number of circular scale division, if it is there is 100 then 100, if 50 then 50, if 500 then 500, then I am taking there is total 100 division in circular scale, 100 division in circular scale. So minus sign for the negative one. Circular scale division, number of division in the circular scale, I am taking over here 100, so 100 minus the value which coincide with the zero of the main scale, with the baseline. Over here it is coinciding, this 45 with the 46, this one 46, it is coinciding, so minus 46. Okay, minus, then 100 minus 46, which comes out to be minus 54. Okay, into the least count, into what is the least count I've already taken. Least count is 0.01 millimeter, so into 0.01 millimeter. Minus 0.54 millimeter. Now what will be the true value? The true value is the observed value minus the negative zero error with the sign minus of 0.54. The observed value was 5.58 plus 0.54, which comes out to be 6.12 millimeter. 6.12 millimeter. Okay, in this way we can eliminate the positive and negative zero error, and we can get the true value if there is a zero error. If there is no zero error, then the process we have done in the very beginning we will find out. I hope everything is clear with you. Thank you for the time.